So let's look at some more examples and talk about how we go from decimal form to scientific notation. Let's take that 14 trillion. So 14 trillion is 14 followed by 12 zeros. As per usual, when I put this in scientific notation, I'm going to take my significant figures, which are simply the 1 and the 4. Put my decimal after the first one. And then I need to account for all the rest of that information in the power of 10. So 1.4 times 10 to the, well, let's see. It's going to have moved 3, 6, 9, 12, 13 spaces to get here. And we'll need to go back all of those spaces for, if you say, for instance, we wanted to convert back, right? Well, this equals it better be true both ways, right? So that means we need something here that would make this turn into this. And as I said, 13 spaces, so it needs to be raised to the power of 13. Some people like to hop one way or bounce one way, you know, with the counting of the spaces, or whatever works for you. I just like to make sure that that equals is always true. Okay. Let's take another example. Say I've got this very small number here. Once again, I will take my significant figures, the 7, 4, 7, 9. It's a decimal point. And to get it there, I had to move 1, 2, 3, 4, 5 spaces. And the negative represents that I'd have to go back this way to get it back where it was. Again, that equals it better be true both ways. So how about those strange numbers where we say that we very precisely measure that something is moving at exactly 40 miles per hour? We mean that to be two significant figures. Well, we had the problem in decimal form where that sure looks like one significant figure. But look at this. In scientific notation, I have the ability to leave that 0 after the decimal and thereby emphasize that it is indeed a significant figure. And there we have it. Another example might be perhaps if I measured the length of something to be precisely 1270 millimeters, right? And I was sure that it wasn't 1200, it was closer to 1270 than it was to 1269 or than it was to 1271. And I really wanted to report it this way, but with 4 significant figures. Well, scientific notation comes to the rescue again, because we can write it like this. All right. We saw before when we were looking at scientific notation examples that there are some peculiar situations where we might have a smaller decimal, a small number, and we want to indicate that there's some significant figures on the end of that as well. So say, for instance, 0.003240. Well, that last micron is important. That last space, the single microns, is important, and so it's significant, right? So here we have 4 significant figures. Scientific notation can make this strikingly clear as well. So we take our 4 significant figures as usual, with decimal after the first one, and put the rest of the information in the power of 10. And here is an opportunity to try. So perhaps pause the video, see if you can do these 4 conversions into scientific notation, and then continue to see how you did. All right, let's see how you did. This will be 1.0 power 9 times 10 to the first power. This will be 1.74 times 10 to the fourth power. 8.7 times 10 to the sixth. And then this one's a little bit of a nuisance, since we have to count all those extra zeros with no commas. But if I'm doing this correctly, I can get 2.3 times 10 to the negative 8th power. All right, then let's try going the other direction. When you have something in scientific notation, can you put it in decimal notation? 1.972 times 10 to the negative fourth, for instance. It'll look like this. Now, the direction to move the decimal point is sometimes difficult to see immediately, but if you think of it in terms of, I've got this very small fraction, this very small number here. This is 1/10,000th, right? So I'm multiplying this number that's between 1 and 2. And I'm going to be multiplying it by this very small number. Well, I better get a small decimal, right? So if I move the decimal the wrong way and I get this huge number, something went wrong. All right. And let's check that. Good, yes. Similarly, then, by the same token, we have this 10 to the sixth, or 1 million, right? That's 1 with 6 zeros afterward. I'm going to get a big number here. I should be moving the decimal place to the right, and by 6 places. This one isn't quite so drastic, but it is still going to be making this bit smaller, yes? So I should be moving to the left. And last but not least, is 5.91 times 1,000 times 10 to the third. There we have it. And now a chance to practice going from scientific notation to decimal notation. Okay, spot this, pause, and then come back and see how you did. And here, that 10 times 10 to the fourth will become 4,918. This one here, with that times 10 to the negative fifth, small number. This one's going to be an even smaller number. Perhaps you saw the pattern here that I'm implicitly exploiting as I do these. But since the decimal is always just to the right of the first significant figure, if I need to move the decimal 7 places to the left, well, I can put my decimal one less than that number of zeros and then start my sig figs. And for the last one, giving that extra 0 because it's